I am Christian Winter, working in the sales company Nordic. I'm application engineer for Seals. I've worked for Parker for 16 years now, and I'm supporting our customers in the Nordic region. I work out of the office in Copenhagen, or outside Copenhagen. Our presenter for today is Dr. Stefan Reichle, who is working for Parker's Engineered Material Group. He's located in Bietigheim in Germany, outside Stuttgart. Stefan holds a PhD in mechanical engineering, and he started working for Parker in 2019 in the automotive sector. Since he has been having different positions in Parker, and now he's market unit manager for the department called Alternative Mobility. I'll just hand it over to Stefan from here.
Also, a warm welcome from my side. First of all, I would like to start with an overview of our typical sealing solution, what we are offering for sealing of hydrogen applications. We can start at typical static sealing solutions like the O-rings. I think that is everybody familiar with the O-ring solutions. We have also another kind of static sealing solutions in our portfolio with additional functions like retention geometries, or with reduced installation forces compared to the classic static O-ring solution. Here we are talking about, by example, about press and place seals. Or we have also extruded profiles in our portfolio if you are looking for sealing solutions in a bigger geometry. For dynamic application, we have also a wide range of dynamic sealing solutions in our portfolio, like the classic lip seals. The classic lip seals are usually used for sealing of pistons or any kind of rods, like in cylinder applications, or will be used by valve applications, like in hydrogen valves. If you have special requirements like cryogenic temperatures in your applications or higher temperature requirements in your application, then we can help you with our PTFE sealing solutions. What is a little bit a different world to the standard rubber sealing solution where you are usually familiar. And if we are talking about really rough conditions in your application, like temperatures up to 800 degrees Celsius and more, or also cryogenic conditions, then we can also support with metal seals. First of all, I would like to talk a little bit about the typical requirements what the sealing solutions are facing in a hydrogen environment or in a hydrogen application. One of the most important requirements very often is the requirement for low permeation or low leakage. Is good pressure resistance, especially if you are talking about tank applications. There often we find pressures up to 700 bars and more. There's also a lot of application where we have to take care about the chemical resistance of the materials. Hydrogen itself is not so the critical material for the most sealing materials, but that material for is also or will be used or part of the hydrogen applications can be critical for some sealing materials, like any kind of cooling fluids or any kind of electrolyte fluids, as example. Very often we are also facing the low temperature resistance. As example, if we are talking about tank applications at cryogenic temperatures, or we have also the requirement for a good high temperature resistance if we are talking about any application which are next by to any combustion chambers. Very important thing is service life. The long lifetime of a seal is one of the basic what the people are requesting for a seal. And another one is what is that have the most people are not so often on the radar is the purity and the cleanliness of the sealing solution, because some hydrogen applications like electrolyzer applications or fuel cell applications are very sensitive to contamination, which can contaminate the electrochemical active layers of the cells inside a fuel cell or electrolyzer system. Here we have an overview about our so-called parliament of material to give you a first idea about the material that we have in our portfolio. The most of them are also usable for hydrogen application. The classic rubber materials, I think, is familiar to the most people, like EPDM, NBR, HNBR, FKM material, but we have also special materials in our portfolio available, like FFKM material. That is a material which can also resist very high temperature in compared to the most other, where the most other material are not resistant against. Also, fluorosilicones. Anyhow, if you are talking about liquid silicones, fluorosilicone, or standard silicone materials, we have fabric reinforced rubber materials in our portfolio, TPU, and a special hydrolysis resistant TPUs, a wide bunch of plastic materials, a lot of different PTFE compounds, resilient metal materials, and we have also in our portfolio solutions which are the composite of the different materials that I have already named, so that as example we can offer rubber metal seals or rubber plastic seals. Here we have an overview about the typical rubber or elastomer material that you can find for hydrogen application. Our first recommendation is always the EPDM material. That is the best price option, which is showing a good performance at in the most hydrogen applications, with a wide temperature range starting at more or less -50 or -60 degrees Celsius up to 150 degrees Celsius. If you have special requirements for low permeation or low temperature capability, then we recommend our butyl rubber. If your application requiring a good resistance against extrusion or a good resistance against explosive decompression, then our polyolefin would be probably a good choice. And if you have any high temperature requirements, then FFKM and FKM are the right choice. If we are talking about leakage, then we have to think about two leakage paths. The first leakage path is the permeation. Here we are talking about the leakage through the material. So that means the gas is going through the material itself from the one side to the other side. And the second path for the leakage is the interfacial leakage. Here we are talking about the leakage between the sealing surface and the seals. So that means the gas is going through any small channels between the seal and the sealing surface, which are inside the surface of the metal plate or whatever. Here's a small explanation what we are meaning with permeation. Permeation can divide it in three main steps. The first step is desorption. That means the material is entering, the gas is entering the material. The second step is the diffusion. That is the gas transport in the material from the one side to the other side. And this third step is the desorption. That is that step where the gas is leaving the material again and is entering the environment. This is all driven by a thermomechanical process driven by the partial pressure difference between the pressure on the one side and the other side of the seal. And for permeation, the permeation behavior of the material is different. Depending on the material class, the materials are showing different permeation performance. As you can see it here on the chart on the left side, the silicone material is one of the material which is showing the worst permeation behavior. The FKM is something what you can find in the middle of this permeation chart. And if you look for the compound with the best permeation behavior, then you have to go to the right side, which is a butyl rubber. Here is an overview about a few examples or numbers about the permeation coefficient in a hydrogen environment and for different materials. As you can see it here, we did we measured that permeation coefficient at a temperature of 85 degrees Celsius and a bar of and a pressure of 15 bar. The best performance was shown by the butyl rubber as expected, followed by the TBU compound, and the last on the list is the EPDM compound. These numbers are the numbers what we have already measured. There is more tests planned or already in the pipeline or in progress. We are also planning tests to do with the materials FKM, with silicon material, and with a special new developed low permeation material. And we were not planning to do this test not only at that condition what I already described, so that means not only at 50 bars at 85 degrees. We are also planning to do the test at 15 bars in room temperatures, at 700 bars and 85 degrees, and 700 bars and room temperature. So here we can give you more updates very soon in future. Also, I'm glad today to highlight our new EPDM compound E8963. That is a special developed compound with improved cold flexibility in compared to the standard EPDM compounds without reducing the physical values of that EPDM compound in compared to the existing compounds like our E540. As you can see it here on the right-hand side chart or table, we were able to reduce the glass transition point from -49 degrees Celsius down to -57 degrees Celsius. So that means more or less a reduction of the low temperature capability down to by more or less -10 Kelvin. So that allows us to use that kind of compound down to -60 degrees, probably for static solutions, also down to -65, -70 degrees, something like that. Parallel, the compound is also showing or still showing a good chemical resistance against brake and water cycle fluids. What is also important if you want to seal against any kind of thermal management fluids. If rubber materials are not longer able to fulfill the requirements in your application, so if you are talking about cryogenic conditions, the most or all rubber elastomers will be hard because the low temperature capability of rubber materials ends more or less between -70 degrees or -100 degrees Celsius. So if you have an application that should work operate at cryogenic condition, we have to think another compound or another material class. In that case, we can talk about PTFE material as example, because the PTFE material has the benefit that they will still ductile at cryogenic temperatures, and parallel they are not showing any explosive decompression problems. Therefore, we have also special compounds available which are showing a low permeation performance and has a good resistance against cold shock, combined with a good chemical resistance. PTFE material is one of the best materials which can resist against the most medias. And with PTFE material, you can have also a quite big temperature window, so that kind of material can work starting at -270 degrees. So that means cryogenic condition up to 330 degrees Celsius. For this cryogenic requirements, we have quite high number of different compounds available. Depending from the rest of the requirements in your application, we can do the choice accordingly. Another material option beside the elastomer and the PTFE materials are the metal sealing solutions or the metal materials. Here we have metal sealing solutions which are made of resilient materials, which are showing a good cold flexibility. We can combine it with a special coatings, soft coatings, which reduce the permeation by closing the interfacial leakage to the by the counter surface. Metal seals also showing a very good cold shock resistance and suffering not under explosive decompression. And also the temperature range is quite big, so starting at cryogenic temperatures, metal seals can be used up to 870 degrees Celsius. Typical material options, I think that is well known, is in Inconel materials, what we can use, like the Inconel material 718. To reduce the permeation leakage, we are offering special soft coatings, like made of coating materials like indium or tin. To reduce the risk for hydrogen embrittlement, what is also an important thing if you are talking about the metal seals, we can also apply a gold or silver coating on the surface of the metal seals. Here we have an overview about the typical sealing solutions for hydrogen. One of them are sealing solution for hydrogen fittings, or we are offering sealing solution for any kind of thermal management solution which are required for hydrogen applications. We can also offer integrated assemblies. What is the meaning of integrated assembly? Here we are combining all the disciplines what we have in the engineered materials group available. So that means we can combine our EMI shielding functions, the sealing technology, and also our thermal management knowledge and products in one product. So that, as an example, what you can see it here on the screen, we can do a plastic cover or lid with integrated EMI shielding function, overmolded, that means direct bonded a seal to that cover, and also integrated some thermal management products like thermal gels or thermal pads, and that we can supply it as one part to our customer. And as already mentioned, we have also composite sealing solutions in our portfolio. That means we are able to direct bond rubber materials to any plastic or metal materials to improve the performance of the sealing itself, or to make the handling in your production much more easier. Also, the risk for any failures of for mishandling of the parts inside the production can be reduced. Then we have a big bunch of different sealing solutions for any kind of housings, like our PIP seals and extruded seals and static and more static seals and hollow profile seals and so on. If you have also the need to compensate bigger tolerances in your application, at the sealing location, we have also special tolerance compensating seals in our portfolio. I will explain it a little bit more in detail on the slides later. We have also a choice of bipolar plate sealing solutions, what we can offer to our customer. I will also explain a little bit more in detail on a few slides later. And what we can also do are smart seals. So if you're talking about smart seals, we are talking about sealing solution where our RFID chip is integrated or a sensor is integrated. A sensor like a thermocouple to measure the temperature, or a pressure sensor. Here we have an overview about the typical sealing solutions what we can offer for fuel cell application, starting at tank systems. Usually here we have the requirement for high pressure seals or for any cryogenic sealing solutions. Also for connector seals, that is also a part that is very often in use for that kind of application. We have also a lot of sealing solutions for the fuel cell subcomponents, which are required to run the fuel cell stack, like any humidifier, air blower, or air compressor, and so on, or filtration systems. Therefore, we have silicone rubber solutions, any kind of permeator gasket seals, or tolerance compensating seals, the so-called warp seals, can be used as well as example. Then we have also a lot of solutions for power electronics application to seal, as example, the busbar connections or any feed-throughs connections. Also the housing, we have any sealing solutions are viable which can fit to that application. And to the heart or for the heart of the fuel cell system for the stack, we can also offering a lot of sealing solution like this, the bipolar plate seals, or also busbar connector seals, or smart seals, or whatever you are looking for that kind of application. Here I can give you a little bit more details about the example about sealing solutions for tank application up to 700 bars, probably also more. Here we have special TPU compounds in use, which are showing a good resistance against gap extrusion, explosive decompression. If you are talking about 700 bars and more, we are always recommending to use for our seals backup solutions as well, which we have also in our portfolio available. The TPU compound is showing is a very impressive material, especially the P5009 material is a very impressive material. He's showing a good cold flexibility. Also at high pressure, what is important, because at high pressure the glass transition point of material is growing up. So that means usually if you have a material which has a glass transition point in ambient conditions of, I don't know, ambient pressure conditions of, I don't know, minus 40 degrees, as example, these can increase under pressure of 300 or 400 degrees up to minus 30 degrees. So that means the temperature range of the material is growing up. Here as an example, there is here on the right side, we see an example for a TPU solution, what is used in the hydrogen fitting of our colleagues who is doing the tube and fittings in the Parker world. They have used the P5009 and has gotten the EC79 certification for this compound, which was proven at the temperature of minus 55 degrees Celsius at 700 bars. Here's some additional point or benefit of that material. The TPU compound P5009 is not getting damaged by cooling down below the glass transition temperature. Usually the most materials are getting hard like glass below that temperature and can be destroyed. That compound is showing a good resistance also against shock freezing. So that for this reason, this compound can be also used as an example in boil-off pipes where you have a short contact with the cold gases, exhaust gases coming from a cryogenic tank, and can resist against the cold conditions for a short time. And after it's getting up again to a warmer temperature, the material is not losing any performance. As you can see it here on the right-hand side on the charts, there's no differences in the numbers between the cold shock freezing and after the cold shock freezing. We did the test on an O-ring. Also, we did a test also on some special specimens. As I already announced, we have also special seals for to bridge bigger tolerances in your application, especially for feed throughs. For feed throughs or for connector of the stack connector plate, as example, you are facing very often problems with the tolerances, what can be not covered by the standard sealing solutions. For that reason, we have developed special sealing solutions which can bridge bigger axial misalignment or radial misalignment, and also are able to bridge angular misalignment.
So Stefan, just a quick one here. Time is running fast, so
okay.
Maybe.
Then I will accelerate a little bit and jump through the last 2 or 3 slides a little bit quicker. Okay,
Please
many
do.
thanks for the reminder. Therefore, as different base profiles available, like our V-warp seal, M-warp seal, and S-warp seal. Depending from the design, we can cover misalignments starting at 0 to 0.5 millimeter up to more as 1 millimeter or higher. And here's, I think, one of the highlights here. We are talking about bipolar plate seals. Here we can do bipolar plate seals made of elastomer material. Here we are talking about full rubber elastomer materials. Therefore, we have specially developed compounds available. We can do that seal with a standard tooling process, or if a higher or bigger parts required, also in the endless tooling technology, where we splice the extruded part to the final together to the final geometry. Also, we can offer overmolded frame seal solutions for bipolar plates. So that means you have a carrier part where we bond on or overmold the seal, or if you have not a carrier frame in your application, we can also do it directly on the bipolar plate seal, on the bipolar plate. Therefore, also special compounds are viable that reduce the risk for any handling efforts, or reduce the handling efforts and reduce the risk for any assembly mistakes. And finally, I think that is more or less this last slide. For special requirements like for alkaline electrolyzers or alkaline fuel cells, we have special bipolar plate sealing solutions in our portfolio, which are made of PTFE material, special PTFE material, which are showing a good performance under load, so that the material is not creeping too much or not doing too much or not showing too much deformation. Therefore, we can do seals up to diameters of 4.5 meters. So in big sizes also available with a thickness of 3 to 20 millimeters with very strict tolerances. Yes, and we can also do testing of that gasket materials in-house. Yes. Then for more details, you can also check out our online Pretiva hydrogen product site under parker.com at Pretiva hydrogen. There you will find more information. So many thanks for your time. And then we will check if there are any questions in the chat.
Yes, so there is a couple of questions. So Juho from Teka was asking if there is an O-log fitting in the range of 700 bar, and the question to that is yes, there is. Yeah, and if you need more information, Juho, please feel free to reach out to your Parker contact. And if you don't have any Parker contacts at the moment, you will receive a mail at the end of this presentation. So there will be contact persons as well. Then Jan-Erik Skåli, he asked or commented that polyamide is supposed to be a good material with hydrogen. Is there a reason that we do not present that as a sealing material? But that is, as I answered, hard plastic materials are not good sealing materials. So that is why we don't consider this as a sealing material.
Yes, it's not a standard sealing material. So, some people are using this in some specific application as a sealing material, but the most plastic materials has no elasticity. So that means they're really, really hard, let me say, and unflexible. So for that reason, if you have any movement, and usually you have some movement by temperature reasons or pressure reasons, pressure changing reasons, or whatever, the material is not able to follow the movement of your housing and the sealing surfaces due to the stiffness of the material. So for that reason, we recommend always to have a material which can follow such movements like rubber materials or other elastic materials.
Yes.
But we can use a polyamide frame and can overmold it with a rubber seal as an example.
And we ran 5 minutes over time here, so this will be the end of this breakout session. So please feel free to reach out to us if you have any sealing related questions. We are able to support on that. So thank you from here.